Hi folks, Mr. Long here. I'm going to do a screencast today to prove the sum of cubes formula. And it's a factoring formula that is new to you this year. It is proven with the factor theorem. So given that we've just done the factor theorem, it's a nice application of it. There is also another proof, of course, called the difference of cubes, or for the difference of cubes, another type of factoring. So I'm going to demonstrate this one for you. In this screencast, it's going to be up to you to develop the difference of cubes, okay, after we do the sum of cubes together. So what we have right here, folks, is in fact the difference of cubes formula, okay, right there. So that's your difference of cubes formula right there, okay. So what we need to do is prove it. So a cubed plus b cubed factors to this, and we need to prove that. So we're going to be working a lot with letters today, right? We can't work with numbers because we're going to generalize. So here's what we're going to do. We're going to create a general function called p of x equals x cubed plus z cubes. Z is just some real number, okay? And it could be 2 cubed, it could be 3 cubed, it could be 5 cubed, etc. Right? So it's just a general number. It belongs to the real numbers, okay? So the letter Z is just any number. So we're going to use factor theorem. Well, what's the first thing we do with factor theorem? We try to find a single factor, and we do that by testing to see if we can get an x-intercept. Okay, we want to get an x-intercept. So let's do that. Let's get an x-intercept. This is actually much easier to get an x-intercept than you might realize. So what we have to do is set x cubed plus z cubed equal to 0. Well, that's pretty darn easy, because then x cubed is going to equal negative z cubed, right? X cubed will be negative z cubed. And if x cubed is negative z cubed, I just take the cube root of both sides, and I'm going to get x equals negative z. Well, look at that. That is an x-intercept. So if x equals negative z is an x-intercept, what is the factor? Well, the factor is going to be x plus z. So I know that a factor of this is this, okay? I definitely know that's true. So again, that's the factor theorem, right? I know, so what I did is I proved that x equals negative z is an x-intercept of x cubed plus z cubed, therefore x plus z is a factor. Okay, x plus z is a factor. All right, so from there, what we need to do now is go through the rest of the process. So here's what I know. I know that x plus z multiplied by some trinomial, x squared plus bx plus c equals this x cubed plus z cubed. Okay, so this right here, x plus z, the factor that I know now, multiplied by some trinomial factor, works out to being x cubed plus z cubed. The only thing I need to do now is to figure what b and c are. Okay, how do we do that? Well, I need to isolate this. How do I isolate that? I need to divide both sides by x plus z. So it means that x squared plus bx plus c is going to equal x cubed plus z cubed divided by x plus z. Okay, so I need to carry out that division. How do we carry out that division? You can use the method of long division. You can use the box method. I think in our class we're preferring the box method, so that's what we're going to do. Okay, so the numerator, okay, the actual function is this, that's our polynomial we're dividing. So that has x cubed, but it also has 0x squared, 0x, and z cubed. Remember that we need the zeros there for place value, right? We definitely need the zeros for place value. So now let's go through the process that we always go through. Okay, the process that we always go through. So if we bring this to here, then what we've got is the x cubed, right? That x cubed comes there, and now we start working through it. So I know that the factor that I do know is x plus z. Okay, x plus z. So what does x multiply by to get x cubed? X squared. Then I do x squared multiplied by z, which gives us zx squared. Remember that z is just a number. It could be 2, it could be 3. So it's like saying 2x squared. Okay, I know that this diagonal has to add to 0. So if that's zx squared, this is negative zx squared. Okay, what do I multiply x by to get negative zx squared? Negative zx. Okay, and now I have to expand through the box. Negative zx times negative zx times by z is negative z squared x. Again, this diagonal has to add up to 0x. So this is going to be positive z squared x. Okay, what do I multiply x by to get positive z squared x? I'm pretty sure that that is just z squared. Okay, z squared. So now I have z squared multiplied by z, which gives us z cubed. And that makes us very happy because this goes to here and we can see that the remainder is 0, which it should be because we know that x plus z was a factor of x cubed plus z cubed. Okay, so we've got that. So that means our answer is this right here. X squared minus zx plus z squared. Okay, so let's write that out. X squared plus z cubed equals x plus z as a factor multiplied by x squared minus zx plus z squared. Okay, so now we want to generalize this. We don't want to have a formula that's just based on x. We want to generalize it to a and b. Okay, just like we know that the difference of squares formula is a minus b, a plus b, or the product of those two equals a squared minus b squared. So we want to do the same thing. So we can take this and let x be a, and let z be b. So we know that a cubed plus b cubed is then going to equal x plus z is then going to become a plus b, and x squared is going to become a squared. Zx is going to become ab. Z squared is going to become b squared. And now we have proven it. Okay, so that's the formula that we were trying to prove right at the start. So what's an example that we could use? Okay, what's an example we could use where this is applicable? Well, supposing you had this question. You were supposed to factor x cubed plus 1,000. Okay, you had to factor it. Well, you can see that x cubed is a cube. Is 1,000 a cube, a cubic number? Yeah, it is. It's 10 cubed. Okay, so I have x cubed plus 10 cubed. That gives me a cubed and b cubed. Now I can put it into the formula. So it becomes a plus b. So I know that a is x. I know that b is 10. Then it becomes a squared, which is in our case is x squared. A times b. A times b is 10 times x minus 10x. The minus sign comes from the general formula, right? And then we have plus b squared. Well, in this case, b is worth 10. So it's plus 100. Okay, folks, and that is the factored form. Okay, that is the factored form of x cubed plus 1,000. Why would you do that? Certainly not for solving equations, because if you have x cubed plus 1,000 equals 0, it's very easy to figure out just by inverse operations that x is negative 10. It does become important, just like a lot of the things I'm saying, in calculus when we're simplifying expressions. Okay, it's just going to be another tool in our toolbox to use to simplify algebraic expressions that leads us to determining things like derivatives and limits, which are critical pieces of calculus. Okay, folks, so that's the proof of the sum of cubes formula and an example. You need to go through that again if you need to. I would encourage you to do it again. Try to develop it yourself, and then you're going to prove the difference of cubes formula. You're going to prove the difference of cubes formula. Okay, and I need to see you working through that before I give you some help on it. Okay, so you've got to try to watch this video if you need to again, and step by step it's going to be basically the same. There's just going to be changing. Instead of x cubed plus z cubed, you're going to be working with x cubed minus z cubed, right? That's what you're going to work with. Okay, folks, so good luck, and make sure you work through that.